1, 2, 3, eyes on me.
1, 2, eyes on you.
So we're doing kind of like what we did on Friday. We did our number lines, right? And we split them up into equal parts. And we labeled each fraction. Do you guys remember that? Give me a thumbs up if you remember it. Thumb sideways if you just kind of remember it. Thumbs down if you have no idea what I'm talking about, either because you weren't here or you don't remember. Some of us weren't here. So we'll review after we do our problem or our application problem.
I remember.
All right. So, who remembers the rule that what we do when we're trying to find our whole number fraction? Like if I was trying to find the whole fraction for 1 and I'm splitting it into thirds, what would I do? What would my whole number fraction be? Chimeria?
3 over 3.
3 over 3. Because when it's one whole, the top number and bottom number match, right?
Mm-hmm.
What if I was trying to find the whole number fraction for 2? Brooklyn, what do I need to do?
I mean, 2 over 2.
No. And I'm splitting it into thirds, and I'm going to have 2 wholes. Ricky?
2 over 3.
No.
Wait, I mean 3 over 2.
Who remembers the equation that we wrote? We said our numerator, right? Our numerator is our top number, divided by our denominator, the denominator is the bottom number, equals our whole number. So, if we're splitting into thirds, do we know our numerator? No. Do we know our denominator?
No. Yes.
What's our denominator? Raise your hand.
2.
Ricky, what's our denominator?
2.
No?
3.
3. So our denominator is 3. So something divided by 3 equals our whole number is, Micaiah? 2. So we don't know our numerator, we know our denominator, and we know our whole number. What can we do to use our reciprocity? I can't pronounce that word. Reciprocity rule. Ricky?
6.
What equation am I going to rewrite? Chimeria?
3 times 2.
Yeah, something equals 3 times 2, which equals what, Ricky? 6 equals 3 times 2. So my numerator is? Maurice?
6.
6 over?
6 over 2. I mean 3.
Over 3 is my fraction for 2. Wholes, for 2 wholes. All right. Our application problem. I'm going to pass it around. And while I pass it around, I'm going to read it with you. It says, Sammy sees a black line at the bottom of the pool stretching from one end to another. She wonders how long it is. The black line is the same length as 9 concrete slabs that make the sidewalk at the edge of the pool. One concrete slab is 5 meters long. What is the length of the black line at the bottom of the pool? You're going to need to draw a picture or a tape diagram or a line plot to show how you would find what the length of that black line is. Me? All right.
I don't know what to do.
Well, let's reread it then. All right. It says, Sammy sees a black line at the bottom of the pool stretching from one end to the other. So let's draw that. What does he see?
A
black line. So the first thing you're going to do is draw that line that he sees. That's the first part of your picture.
What?
She wonders how long it is. So what are we trying to solve for?
How long?
How long the black line is. It says, the black line is the same length as 9 concrete slabs. How can you draw that? It's the same length as 9 concrete slabs. Oh, I see some people are starting to think of what they can do. I see some number lines starting. I see. Ooh, nice job. Ooh, I see some people are even labeling it already. I see a lot of people, they drew a number line and they split it into 9 sections. So if I'm splitting it into 9 sections, how many lines am I going to draw? 8. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I need 9. I need one more. One more. 9. The next part of the question says, one concrete slab is 5 meters long. So one concrete slab is 5 meters long. What's the length of the black line at the bottom of the pool? If each of our sections represents one concrete slab, and each slab is 5 meters long, how long is the whole thing going to be? So I see some people, instead of drawing a number line, drew a tape diagram. There we go. Tape diagram some people are drawing.
I did it on number.
Each concrete slab is how long?
5.
We're not doing fractions yet. 5 meters. So if each of these sections is 5 meters, if I had my tape diagram, I drew a tape diagram here, I would have 5 meters inside of each of it, each of the spots.
Oh, I know. Then we can,
On the number line, what would I write on each of these marks? Not fractions yet. What would I write for the length at each mark? What would I be skip counting by? Jalecia? Not tens. How long is 1? Jalecia, how long is one of the concrete slabs? Do you remember? I know.
1 meter?
5 meters. So I would skip count. I start with 0, right? We have 5. What's next?
6. I did everything.
Skip counting by 5. Next is
15.
then
20. 35. 30. 35. 40. 50.
nope. What's after 40? Skip counting by 5.
45.
45. So how long is the black line?
45.
45 what's?
Meters.
45 m or 45 meters.
Can you say
M stands for meters, so you can just write lowercase m.
It's because I skipped count and I got 45.
Good. What if we wanted to write a multiplication problem for this equation instead? What would our multiplication problem be, Kamiria?
9 times 5 equals 45.
Yeah. We could also say 9 times 5 equals 45.
It's because I wrote the thing so hard and I put so hard on it.
Alright. I'm going to give you a minute.
Oh. I don't want to race it out anyway. I just have to answer it in my head. Yes. Everyone. Are you coffee? No. About the pie.
All right. Yes.
I don't really eat erasers. I usually eat this thing. A block of erasers.
Alrighty. Let us move on to our equations for today. I'm going to give you your problem set to follow along with.
This is easy. Is it
Put your name on the top first.
You didn't put the date. Oh, you don't need to put the date. The date you can if you want. Yeah, but you never put the date. I do.
I love seeing how many people took notes and practiced our application problem with us. All right. Today, we are focusing a lot on finding those whole number fractions. It gives us a bunch of fractions, and we have to find where on the number line it belongs. Remember, we have to find if they're in between 0 and 1. Sometimes we have to find if they're in between 1 and 2, or 2 and 3. So we're going to have to practice splitting up the number line. And we're only labeling the ones that our page is showing us, okay? So we have, oh, that marker doesn't work very well. We have
a big line.
a nice big line. What's my first number?
0.
0.
And the end?
We have 1, 2, and it ends at 3, right?
Yes.
Alrighty.
Why so long?
Why so long? Because we have 3 different whole numbers, including 0, 4 different whole numbers to separate it by. Yeah.
Why do we go like we go to count this like 1, like 0, 6,
Mm-hmm.
12, you didn't go back to 3 over 6 and 9. It only makes sense.
Yeah.
Like what?
Alright. Let's bring our focus back up here, tracking the speaker. 3, 2, 1. Before we start finding where on this line all of our fractions go, we need to draw our intervals, splitting it up into the different parts. Let's look at those fractions. We know that we split up each whole number into a certain number of sections based on the denominator. What's the denominator in all of these fractions it's asking us to find? Chimera?
6.
6. So how many lines am I going to draw between 0 and 1? Show me on your hands. How many lines am I going to draw in between 0 and 1? I'm going to draw 5 lines, because if I draw 5 lines, let's see, 1, 2, 3, 4, 5. It makes 1, 2, 3, 4, 5, 6 sections. That's like having 6 pieces. So I want you to draw your intervals. Draw your lines.
I did it.
Good.
Oh, we have to draw them bigger.
Yep. Remember to try to space them out evenly.
Mine was even.
Try to space them out as evenly as you can.
Wait, are we gonna do the answers? Yeah.
This is how we start the answers. We have to find our intervals so we know where some of the fractions can go.
I draw 6.
How many lines am I going to draw between 1 and 2? Raise your hand. Maurice? 5 fraction pieces. 5 more. Because we have 6 sections in between each whole number. So again, you're going to put 5 lines to draw 6 sections between 2 and 3, because we put 6 sections in between each whole number.
So, this is that.
Make sure you spread them out like this one. Do you see how these are all spread out?
Yeah.
if you can, okay, erase these numbers. We need to spread these out evenly. See how mine are spread out? Yep, like that. You guys are awesome at spreading your lines out evenly. Nice job. Nice job, Dylan. I'm looking.
Okay, it's called pub.
5 lines inside of each. All right. Give me a thumbs up if you're ready. All right, we have a few more people still drawing lines. I'll give you 20 more seconds. I'm gonna keep going. All right, now let's see if we can find where these fractions belong. Our first fraction is 0 over 6. Raise your hand if you know where our fraction of 0 over 6 is going to go. Manny, do you know where 0 over 6 is going to go? Do you want to call on a friend to help you?
At the beginning.
At the very beginning, because 0 over 6 means there are 0 pieces of the fraction. If we have 0 pieces of our fraction, we have nothing. We have 0.
It already says that on our paper.
It does. Our second fraction is 6 over 6. Hey, we already talked about this today. If the denominator and numerator match, that means it's going to be what, Julicia?
7? 1 whole.
6 over 6 is going to equal what, Emiliano?
1 whole.
1 whole. So our 6 over 6 goes right on the 1, because it is 1 whole.
So we put it on 1. No, they did it for us. Did they do it for us? Yeah.
Nope, they didn't. You're writing it. You are writing it. After you write it, you can even cross out the fraction on your page so you know you've done that one already. The next fraction is 12 over 6. I'm going to show you a hint of what we can do to find 12 over 6. Hands down. I want your eyes up here. We're going to pause writing. For 12 over 6, remember we can count each of these intervals, each line, we add 1 to the numerator, right? So we can count up to see where 12 over 6 would be. So we have 6 over 6, 7 over 6, 8 over 6, 9 over 6, 10 over 6, 11 over 6, 12 over 6. Let's write 12 over 6. And that's on a whole number. Should we check our work by doing our division problem?
Wait, which one are we on?
12 over 6.
I do that.
Let's check.
Where do I write it at? Go back to.
Where did I write mine?
Oh.
Over the 2, because we said 12 over 6 is equal to 2. We counted up. Let's check our work to see if 12 over 6 equals 2. We're going to do our division problem. Remember that one? Our numerator, which is what? What's our numerator?
12.
12 divided by our denominator, which is?
6.
6 equals our whole number. Let's see. 12 divided by 6. That means, how many times do I skip count to 12? Let's see. We have 6, 12. How many times did I skip count? 2. Is that correct?
Yes.
Yes. Thanks for checking your work with me. All right. Next. Fraction is 3 over 6. What can we do to find where 3 over 6 belongs? Maurice?
We can go back.
Back to 0.
I'm gonna tell that this is 1/6.
Oh.
6.
So go back to the 0/6 and count up.
Yeah.
Yeah, so he went 0/6, 1/6, 2/6, 3/6. So 3/6 belongs on that 1, 2, 3rd line. And our last one, Marquise, is what? 9/6. Do you have an idea where 9/6 is going to go, Marquise? At the 3? Not quite. Where could we start to count up to find where 9/6 would be? Is 9 bigger than or smaller than 12/6? Smaller than. So maybe I should start counting at 6/6.
Yeah.
Count with me. We have 6/6, 7/6, 8/6, 9/6. So my 9/6 goes 1, 2, 3 lines after 6/6.
1, 2, 3 lines.
So we counted 6/6. If we count 7, 8, 9/6, or 9/6.
So.
Raise your hand if you have any questions about how we did this. Is anyone confused about how we found where each fraction went? All right. Then let's start number 2 together, and you're going to finish it for me. So we're going to start it together, and you're going to finish it. We have whole number 1, whole number 2, whole number 3, and whole number 4. Are we starting at 0 this time?
No.
No.
Not 1.
So this one's a little bit trickier.
1/4. Right. So I don't know how many lines do you press right there. I don't know how many lines.
You can write small, or you can write it to the side and draw an arrow to where it belongs, Millie.
Yeah.
What's the first thing we need to do?
We need to write 3 lines.
Oh, hold on. There are some people that are speaking out. We need to have our voices off unless you raise your hand. And we need to track the speaker. So right now, Maurice is going to share what we need to do. So let's track him or track the board. Say that
So we
again.
can write 3 and then we can go to the next one. Write 3 in there.
Oh, so we're going to write 3 lines? Why are we drawing 3 lines in between each whole number? Why are we drawing 3 lines inside each whole number? Because we're splitting it into fourths. Yeah. He saw that the first fraction we need to find is 8/4. So he knows we need to split each whole number into 4 sections. So let's do that. Oh, this last one's really big. Let me make that smaller. I don't need that big. So we are splitting each of our whole number sections on our number line into 4 sections. And there's 4 sections when we draw 3 lines.
4. You're supposed to write 3 lines. Yeah, 3 lines. And there were 3 lines.
Before you start finding where those fractions are, we're going to do 4/4 first. Because we need to find what our whole number fraction is so we know where to start counting from, right? What's our whole number fraction going to be if we split these up into fourths? Ricky, do you know what our fraction is for 1 if we split it up into fourths?
1/4.
No. Our whole number fraction. Do you remember what that is? Micaiah? Nope, that was 0. What do we do for 1? Nariah, do you want to try it? No? 4/4. Remember, when it's 1 whole, we have our numerator and denominator match.
I gotta do this. So after 1, like say it was 1/0. Say it was 1, and then you count by 6. So if you 6/6, then
Yes.
just, do the same amount of that.
Yes. So now, when you are finding the rest of your fractions, you can start at 4/4, and you can count each of these lines. You add 1 to the numerator or the top number. So this is 4/4, 5/4, 6/4, and you keep going. I'm going to give you 2 minutes to see if you can find where each of these fractions go.
Wait, the whole. Oh, okay.
So see if you can find this fraction. See, 8/4. Alright, or do it now. So this is 4. 5/4. 6, 7, 1, 2, 3, 4.
And then. It's really easy. I really messed up. I have to go back and easy. I'm done with the question. Question 2 is easy.
This is 4.
Look, you can tell there's water.
7/4.
It is water. Why would they put gel in? Not that kind of gel. I know. Yeah, I know. It doesn't feel.
Alright, I'm giving you 45 more seconds.
What? You get it out.
We're going to go over it.
If you want to in the okay.
Nice job. Let me check.
You would have someone, but they went out. So they said, we will be stuck.
1, 2, 3, 4, 5, 6, 3 lines.
It's been 4 days, so they might check. You're on the right track. No, you're on the right track.
3 lines.
You're on the right track. Making her at my
So on the right, nice. You okay? What's wrong?
I messed up. Done. And I messed up. I'm on the right track. I'm on the right track.
All right. Let's bring it back up here in 5, 4, 3, 2, 1. Who can tell me where did 8/4 go? Lauren.
2.
On the 2. 8/4 is on the 2. Our next one was 6/4. 6/4. Brooklyn?
It will be the 4, but you go 2, right?
So we started at 4/4. She counted up 5/4, 6/4. So it was the second line after 4/4. Our next one was 12/4. Chimeria.
On the 3.
It's on the 3. 12/4.
Who's math?
Our last one that we didn't do yet was 16/4. Where does 16/4 go, Maurice? On number 4. 16/4.
That's
Good.
Well, I was counting the fraction. I didn't. Okay. I want to do
All right. I want to do number 3. Let's start number 3 together.
How am I going to do?
We start with 2. Our next whole number is 3. And it goes up to 6. 3,
And then
4, 5, 6.
So it's going to
We're trying to find 18/3 first. So how many sections are we splitting our whole numbers up into?
6.
No. Check again.
I know. 3. The sections are 3, but we're adding 2 lines.
3 sections, so we're drawing 2 lines. 2 lines in between each whole number. So between 2 and 3, we're drawing 2 lines. Between 3 and 4, 2 lines. 4 and 5, we're drawing 2 lines. 5 and 6, we're drawing 2 lines. Remember to try to make them evenly spaced.
I think it's supposed to be 8 lines total.
So that there are 3 sections between each whole number. Manny, if you need to tap, tap on your lap. Because it's quieter when you do it on there.
3, 4, 5, 6, 7.
All right, 1, 2, 3, eyes on me.
1, 2, eyes on you.
Let's find what our fraction would be for 2 wholes so that we have a starting point to count up from. Who remembers what our equation is for finding our whole number fractions? Who remembers? Julicia?
18 and 3.
No, what's our equation? Like what times what equals what? Maurice?
It would be, yeah, I know it. It would be 9.
Nope. Our equation, let's remember, is our numerator
Oh. No.
divided by our denominator equals our whole number. And we can flip it, right? By saying our numerator equals our denominator times the whole number.
Oh, I didn't know.
Do we know our numerator?
No.
Nope. Do we know our denominator?
Yeah.
What is it, Samaria?
3.
3 times, what's our whole number?
W.
Oh, no, what number is our whole number? What number are we trying to find?
3.
What whole number are we trying to find? 2. What's 3 times 2?
3 times 2.
6.
Ricky? 6. So our numerator is 6.
6 over 3.
So
That
2.
makes kind of sense because the 2 and the 3 and 1, 2, 3. But that's how my mom was saying. Like, I don't know.
2 and then 1, 2, 3. Then you have a 6 and a 2.
All right. We have
Wait, what is it?
6 thirds. 6 over 3 equals 2 wholes. Now, we need to find 18 over 3. Let's count up. So we have 6. We start at 6, remember? Because 6 is our numerator.
7 over
7 thirds, 8 thirds, 9 thirds, 10 thirds, 11 thirds,
12, 13 thirds,
14
thirds,
16 thirds.
17 thirds, 18 thirds.
So 18 thirds goes
Right by 6.
on the 6. Should we double check it using our equation?
Yes.
Let's double check it. So our numerator is 18. And our denominator is what?
Our denominator is 3.
3. Let's see, times 6. Let's see. Let's skip count by 3 6 times. Skip count with me.
3, 6, 9, 12, 18,
15, 18. Are we correct?
Yeah.
Yes, we are. Thank you for double checking with me.
Good job.
All right, next is 14 over 3, 14 thirds. Should we count up from 6 or should we count backwards from 18?
We should 18. We should go
Let's try counting backwards. Let's start at 18. What's before 18?
18,
17, 16, 15,
14.
14. 14 thirds. So that's where 14 thirds will be.
Right in the middle.
Yep. So count with your fingers on your paper so that you write it on your correct mark.
14,
Next, we're finding 9 over 3, 9/3. Let's start at 6/3 and count up. So we have 6/3, 7/3, 8/3, 9/3. 9/3. And our last one is 11/3.
Oh, I know this one.
Let's start at 9/3 and count up. So we have 9/3, 10/3, 11/3. Oh, that one was easy. That one wasn't too far.
I know 11. Now I know the other one.
We already did the other one. We already did 6 over 3.
Oh, you?
Yep. All right, flip your paper over to the back side when you are done.
I had it. Yeah, look at that.
Flip your paper over to the back so I know you're ready. Few more seconds to finish.
9 and 3, 11 and 40.
All right. We have our word problems. You ready?
Yeah.
For a measurement project in math class, students measured the lengths of their pinky fingers. Alex measured 2 inches long. Jeremiah's pinky finger was 7/4 inches long. Whose finger is longer? Draw a number line to help prove your answer. All right, so first it told us to draw a number line. I need us to keep our voices off, and if you have something to add, raise your hand, please. All right, let's draw a number line. What's the first number on our number line?
2?
Nope.
Oh, I mean, 0.
0. And we know it goes up to 2 inches long, right?
Yeah.
So what number has to come in between 0 and 2? What whole number? Jalicia?
1.
1 needs to come in between 0 and 2. One of them measured with fractions. What fraction did he measure his finger in, Jeremiah? Yeah. 7/4. How does that help us know what to do next? How does knowing that he measured in 7/4 help us know what to do next with our number line? Right now, can we mark 7/4 on here? No, what do we need, Trent? What do we need in order to draw, in order to show where 7/4 belongs? Say that again. We need to draw what? Can I just go 7/4? No.
Oh, I know.
What do I need to do on this number line to prove where 7/4 needs to go? Micaiah? We need to draw our intervals, right?
Yeah.
We need to draw our lines. We know we have our denominator of 4. I like silent dance. We have our denominator is 4, so we need to split it into 4 parts. How many lines are we going to draw? 3. Am I drawing 3 total lines?
Yeah. No, but it's
Like
not
1, 2, 3? No.
In each one.
I draw 3 in between each one. That's right. The first thing we're going to do is mark where Alex's finger was, because Alex's finger was 2 inches long, right? So I'm going to label it A for Alex. I'm going to draw a dot and label it A for Alex.
You have to do that too?
Yep. Now how are we going to find where Jeremiah's finger belongs? What are we going to do?
I don't know. So he said, I'm still writing that one. So we're going to come back.
Are we going to count backwards? Do we know how much 2 is? Do we know what the fraction for 2 is?
No.
No?
Yeah.
What is the fraction for 2? We haven't written the fraction for 2 yet. Could we find the fraction for 2?
Yeah.
What's the fraction for 2 wholes? If we're splitting into fourths, should we do our equation?
Yeah.
Yeah.
All right. Do we know our numerator?
Yeah.
Do we know our numerator? The top number? No. Do we know our denominator?
Yes.
What's our denominator? Oh, Haley says 4. It is 4 because we have 1, 2, 3, 4 sections. Times our whole number, 2.
2.
What's 4 times 2? Someone raise a hand. Come here.
8.
8. Yep. You can put those on my desk today because I don't have that desk there anymore. Thank you. So our fraction is 8 over what? 8 over 4. Thank you. 8 over 4. Where would 7/4 be then?
7/4 will be right next.
Right next door, because 1 less than 8 is 7.
I know it.
So 7/4 is Jeremiah's finger.
I made an S out of we'll go into the lunch and we'll when I get to month then.
Nope, we're still doing math. Alright, we're almost done, guys.
Yeah.
J for Jeremiah. Whose finger was longer? Ricky, whose finger was longer? A for Alex. So what could we write? What should our written part be?
Okay. Alex,
Alex's.
finger is more than Jeremiah because Alex.
Hold on. First, Alex's finger is we've been talking about comparing adjectives. What adjective would we use? Longer. Alex's finger is longer than Jeremiah's, like you said. Because why? Do you want to finish that up?
Jeremiah's finger was 8 over.
Whose finger was 8 over 4?
Alex's was, but Jeremiah was 7 over 4.
So could we write a comparison? Because 8 over 4 is, well,
And I said Alex was
because 8 over 4 is bigger or smaller?
bigger than.
Bigger than 7 over 4, or 7/4. After this, we're going to do our exit ticket.
What are you supposed to do? Right. You know what to do?
I'm going to give you your exit ticket.
Oh, God, no.
Your exit ticket is just like this on the bottom. It gives you a number line with the whole numbers, and you have to find where 3 of the fractions belong. You have to split it up into the correct number of spaces and find where the fractions belong. The second question on your exit ticket is another word problem similar to this first. All right.